because, those apple peels have a lot of certain substances in them that are very wholesome, and one of the reasons they're wholesome is because certain bacteria in the gut that we are starting to think are healthier for you than others. Certain bacteria really like those, and we know that. So, like people who are lactose intolerant, for instance, like what's going on there, right? Like why can't they drink milk? Okay, they can't digest it, but that shouldn't be a problem. The problem is that milk is a really powerful prebiotic. And if you don't digest and absorb that lactose yourself before it gets to your digestive tract, the bacteria in your gut will do it for you, okay? And they will do so in a way that's very, very upsetting for the person who's going through that, right? That's the mechanism, right? In a person, in one of the mutants who can digest milk into their adult life, because the natural, normal human state is to lose your ability to digest milk when you pass into adulthood. But human beings have been selected for this unusual mutation that you retain the paedomorphic characteristic of, lactase production into the adult life. It's like, why would you need to be able to digest milk when you are not a baby anymore? What are you going to do? Like, suck milk from a cow or something? Like, And that's been selected for, and that means that we break down that lactose material and absorb it, so it's gone before it hits very far down in the gut, right? But if you don't produce that enzyme, that lactose goes further down in the digestive tract, and then E. coli is like, well, if you're not going to eat it, and then it makes a huge mess in there, and people start vomiting and having gas and having to run to the bathroom and all kinds of problems like that. So
is that why babies who drink a lot of milk might not necessarily poop a lot?
Yes. You notice when you start raising a newborn, you're like, where is all this going?
Yeah.
Especially if you had multiple kids. You're used to the diaper load that you get towards the end, and then you have another kid, and you're like, this is wonderful. Like, this is easy.
Yeah.
They poop once a day. Oh, that's fabulous.
Yeah.
And not even every day. And then when they do, it's like a tiny little bit of cottage cheese at first. Like
Yeah. It's really interesting because my husband, he's lactose intolerant, and if he, like, my daughter didn't eat all of her cereal, and she drinks regular milk, and so he had it, and the next day he was running to the bathroom constantly, and
Yeah. So that's because your gut is loaded with E. coli, and just like that monster in there eating that whatever muffin or whatever that fell from the sky, E. coli will love to eat any lactose that gets into you. But that process of E. coli throwing a party whenever lactose reaches it is not, in that particular case, it's not a fun thing for the person involved.
No.
Other prebiotics are actually, good for you. It depends on sort of what happens down there. So it's a new field of science, and people are only beginning to understand some of the complexities of what happens there. We know, for instance, now that like people who are obese have a different gut microbiome than people who are not obese. But then it's like, it's like a chicken and the egg kind of problem, right? Like which of these cause the other, right? Like is there a relationship? Like did this person get fat and then their microbiome changed because they ate like an entire gallon of ice cream last night, or did they eat an entire gallon of ice cream because their gut bacteria had an influence on their thinking or something like that, and made them do that, right?
Doesn't it kind of depend upon their genes too?
Yeah, there's also genetic components as well and everything like that. So we know that different people can tolerate different diets differently and so forth. All right, so now we go into the eukaryotic organisms. Now, the eukaryotic organisms, we break that into kingdoms, right? And then we got some really good, clearly defined kingdoms, right? We got Animalia. And the animals are multicellular organisms that can move at some point in their life cycle, and most of them take food inside themselves to digest it, right? So internal digestion, at least intracellular digestion or something like that, right? So animals don't usually like reach out and put their hand on something and dissolve and then absorb it like that, right? They'll take that food particle into themselves and into a central chamber if they can, if they have such a central chamber to digest it. So multicellularity, motility somewhere in the life cycle, and intracellular digestion, those are the characteristics that make up an animal. On the other side of the spectrum, you got the plant. Plants are also multicellular, right? plants are autotrophs for the most part, okay? The non-autotrophic plant, okay, this is Indian pipe. It's a non-autotrophic plant. It's a parasite, and we can tell that this evolved from autotrophic ancestors.